All right. So this week we're in Lab 1, and half of you have already gone to lab and worked through this. And once again, this lab involves going to this tutorial and doing the 6 chapters that are listed here. So in this tutorial, the tutorial demonstrates different commands that you can run at the Linux command line prompt. And I'll review those commands as we go along, but in the context of solving some problems. So I'm not going to just go through those one after another. That's what you'll do in lab. And then when you're finished going through that tutorial, then you need to write this hello program. I think we did this last time, right? We did that last time. We can repeat that. And so what I want to do is to sort of jump forward and start looking at Lab 2. And it's good for you to kind of try to keep a few steps ahead. So if you get busy during the quarter, you can always back off a little bit and not fall behind. All right. So we're going to try to stay a little bit ahead of the labs and the assignments during lecture. All right. So in this lab, we're going to learn how to use a version control system, and a specific version control system called Subversion. And we're also going to talk about reading from the keyboard, getting input from the user in a program, and writing to the console. Right? That's called output. So input and output. Now, a version control system is a program, a client-server program. Doesn't actually have to be client-server, but what we're using, Subversion, is a client-server program. There's a server somewhere set up to function as a repository, like a bank, like a backup center, and you'll copy your files into that, and as you go through the course and you solve problems and modify your files, you'll copy your changes and your additions into your repository. So everybody in this class has their own repository. And I sent your passwords out by email. How many people did not get an email with your username and password in it? Can I see a show of hands there? 1, 2, 3, 4. Okay, I sent those to your campus email account. Do you check your campus email account? Some students actually don't go and check their campus email account. So please check your account, and then if you don't see it there, talk to me. Send me an email, and I will send you your password again. All right? So, version control system is something that's used a lot by programmers. And it's mainly used in the context of groups, like group programming activities. And most programming is in a group. Almost all of it. You're working with other people. And so you're working on the same code base locally on your machines, and then you write your changes to the code base into the repository. The other people on the team synchronize with the repository as frequently as possible. They check out the changes, the revisions to the code base. And so there's a lot of there's some new concepts that you need to learn, and some tricks and issues that come up that you need to handle For instance, if two people make conflicting edits to a file, the system will try to merge the changes, but it's possible that the merge operation could be ambiguous. So the system doesn't know how to merge those conflicting changes, and then you need to manually resolve that conflict. But you know, in this class, mainly it's you committing into your repository, and me and the grader, Jaron Willis. We have a grader for this class. His name is Jaron Willis. We'll be checking out your work. So basically, 3 people have access to your repository: yourself, me, and Jaron Willis. All right, let's take a look here. Let's just go ahead and start a work session. This is what you would typically do when you do work on this course, right? So you start up PuTTY. If you're on Windows, normally you would start PuTTY. If you're on Macintosh or Linux, then you would just open a terminal window. And we'll connect to this JBH 3-1. So I've saved the address for this. And this is the account that you use to log in. When you go into the lab and you log in, this is the username and password that you were given in the lab. All right, so now we're into the network, and this is our first step. Now the next step is to log into one of the machines that are in our lab room. So I use the up arrow key here because I'm accessing what's called a command history, right? So it's very convenient when you're working at the command line. And this works on newer versions of Windows as well as Macintosh too. So let's connect to that machine. Let's connect to machine number 5 today. Let's see if anyone else is on there. Nope. Okay, I'm the only one on there. And I think I should increase the font here. Let's do that. So we're at, when we log in here, we're in the our home directory. It's called home directory. This is the path to my home directory. And if you haven't done this already, you should make a directory called CSE201 and put all of your work in there. Well, that already exists. So I use the cd change directory command to change my current directory to CSE201. If I use print working directory, I can verify that yes, I'm now at a different location in the file system. I can use the ls command to list the contents of my current folder or my current directory. Once again, the term folder and directory are synonymous. And so there's our lab 011. And we created a hello program last time. We'll use nano to edit this program. And there's some C++ statements, and the program says hello when we run it. Let's try that. Oops. I don't want to make that change. I thought it was in VI. let me simply exit. This a.out, that's the executable that we generated last time by compiling main.cpp. When we run it, we use that /. When we run it, it just prints hello. And once again, you can't run it by just typing a.out. Command not found. It doesn't, the command processor, the terminal window, it doesn't look in your current directory for the command that you type in. It could. It's just a matter of changing my configuration, and I could tell the command processor to look in the current directory, but I haven't done that. I use the history key, the up arrow and down arrow. Go back in here. Let's see the process here. So we're in the source code in a text editor called Nano. And we'll change, I keep thinking I'm in VI. We'll change hello to bye. I'm going to go Control O to save and Control X to exit. So we modified the program to say bye instead of hello. What do we do next?
Yeah, that one.
What's that?
Oh, we gotta change it.
We have to recompile it, right?
Yeah.
So main.cpp is the source code, a.out is the executable. So we have to use the compiler to tell it to regenerate a.out
Yeah.
based on the changes to the source code.
So you can type in C++ and then main C.
That's it. That's great. And now when we run a.out, there we have it. Okay, that's your basic process right there that you'll follow over and over again for the rest of the quarter. Yeah.
Is there a difference between G++ and C++?
Yeah.
No, they're the same thing.
Because yesterday in the lab, or Monday, I'm sorry.
Yeah.
The guy, he typed G++ instead.
Yeah, it's all the same. So G++. So like I deleted a.out. G++ main. There it is.
Okay.
And it runs. So.
Can you write can you write stuff from here and without using the text editor, or do you have to use the text editor first and then? Because like you know how you modified it.
Yeah.
From here.
Yeah.
Can you write the whole thing in here?
Yeah, you can write the whole thing in here.
Oh, okay.
Yeah, let's we'll do it. We'll do the first problem in lab 2. And we'll just go through the whole process. So you can start up, for instance, if we want another file called, say, main2, you can start Nano like this. It'll create the file for us.
Oh, okay.
There's main2.
So then when you go to main 2, you could just write a whole program and then use the compiler on it and it'll run it.
Right, right. So later in the course, our programs will be comprised of multiple files, right? In the beginning, we're just going to put our programs in single files. We'll call those main.cpp. You could call it something else if you like. It's just my convention that I follow. It's the file that has the main method in it. And let's take a look at that, actually. Let's look at what's going on here. See this word main there. That's the reason I call it main.cpp. It's the file that has the main function in it. So a program, the source code for a program is normally many files, not just one file. And when you give all those files to the compiler and tell it to build the executable, the compiler is going to generate machine code, and then the program needs what's called an entry point. So when you tell the operating system to run the program, the operating system says, okay, what is the first instruction you want me to execute in this block of machine instructions you gave me? Well, it's the function called main. So you can only, so you have one function, you can only have one function called main that's global. and that's called the entry point. So when your program runs, the first statement inside main is the first statement that runs. So I just call it by convention, I call the file with the main function in it main.cpp. Now, a function, and function is a topic, by the way, that we're going to cover in one of the later chapters. I think it's chapter 4. I can't remember exactly. But so until we get there, we won't be creating functions. We'll be using functions that already exist, and we'll use this main function. We'll put all of our work inside this main function. But later on, you'll be defining new functions. And let me show you. So here's a program that does that has 2 statements. By the way, if you look at, see that semicolon right there? That's a line terminator or statement terminator. So that means that that's the end of one statement. So you'll see there's 2 semicolons. So we've got 2 statements in there. So this is a statement. And that's a statement with the semicolon terminating it. And then we have another statement here. Different languages have different conventions. Like in Python, a language called Python, just the end of the line is the end of the statement. And you don't use a semicolon like this. But semicolon is very common. In C# and Java, they use semicolons. And so, you know, to read this, let me go a little, I'll do it that way. To read this program, what you need to learn how to do in this course is to basically learning a language, right? So it's like learning Spanish. I mean, it's not learning a human language, but it's you're learning this language. So that means you're going to learn how to read. So when you see this code up here, you're going to be able to read this. That's the goal. You see this, and you're going to read it. So on the quiz, the first quiz that you'll get, you know, I'll maybe give you this and say, read it, understand this program, and then tell me what does it print when you run it. And you just say, well, it prints hello dot by dot. That's it. You'll be able to read it. And I'll give you another program with maybe a loop in it and a conditional. If, you know, it's raining, put on your raincoat. Else, you know, put on a T-shirt or whatever. And so if you run this program when it's raining, what happens? And then you say, oh, I put on my raincoat. So you'll be required to read the code. All right. So how do we read this code? Well, no, we've already gone over this. This is the entry point. So as you read it, you're going to say, all right, execution starts in the first line within the main function. That's the first thing the program does. So the computer does things sequentially. Well, not exactly. You know, they have things called, you know, multiple processors now. And so they have parallel computation in a typical computer these days. So it doesn't actually do things sequentially anymore. But the programs that we're going to be looking at, execution is sequential. We only do one thing at a time. When you play a video game on your computer, it's not sequential. You've got lots of things going on at the same time, especially in the video card. You've got, you know, dozens of programs running at the same time in the video card. So let's see, what does it do? Well, let's read this. This says C out. Okay, that's a term. It's an identifier. It's a name. It names something. It names this thing called a standard output stream. And by default, that represents the display or the monitor. And so we can perform operations on the monitor. We can say write something to the monitor. Actually, it represents the console window, the terminal window here, because we're running what's called a console program. So this C out represents the standard output stream, which by default is connected to the console window. And then this next symbol here, this is the output operator. So, okay, so we want to output something to the console. And then what follows that is a string. So you've got a quote here, and the quote says, start string. A string is a sequence of characters. Start the string. The first character is an uppercase H. The second is an E, a lowercase e, and so on. A period, a slash, and then an M. And then when we hit this quote here, that's the end of the string. So this is an argument to this output operator. So we're saying, send this, write this string to the console window. And then when you're done that, go ahead and do the same thing again, but write, bye instead of hello.
You always have to put the waka wakas to the left.
Put a what?
Don't you call it waka wakas or whatever? Little arrows.
Yeah.
It's called waka wakas, right?
Waka wakas? I never heard that.
That's what the guy told us they were called the other
He said
day.
they called waka wakas.
I have never heard that. He's pulling your leg. Yeah.
Put them always to the left, though?
No, that's for the output. No, before when you can go to the right. So you might have.
Yeah, when do you go to the right instead?
Yeah, you can do this.
Oh. What does that do?
That's CIN is a standard input stream. So you might have declare an integer x, and we say fetch the next integer from the standard input stream, which by default is the keyboard.
So question, so what are those arrows called? Not called waka wakas.
This is an output. This is the output operator.
And then the other one's an input
This is the input operator.
Okay.
Now you may see those symbols. Yeah, that's right.
So waka waka is like slang then.
I guess. I mean, I never heard that before.
Okay.
Yeah. Maybe because I'm too old, and all the new people are using
You always
different.
put two of them? You can't go left.
Yeah, two. If you put one, it's different. This is this will compile, but this will fail to compile.
So if you put three, would it compile?
No, 3 will fail as well. Let's go ahead and try those things. And just to make things go faster, I'll do it like this. Whoop. Gotta get rid of that. Get rid of that main 2. All right, let's see. And this is actually I want to demonstrate this. So thank you for bringing this up. Let's get this to compile first, and then we'll show what it looks like when it doesn't compile. This here. So we're going to let's build that. Let's run it. There it is. Oop. It's waiting for a number. See, there's a reading from the
Oh, really?
keyboard. Yeah, waiting for a number.
So, okay. So the int x means you type in a number, or
Int x means allocate memory to store an integer. Call it x. And it's the next line that says read in a number and store it in x.
that's the one that you're gonna type in.
Yeah.
Okay.
This is the one where you type it in. This says this is allocate storage for an integer. That's int is short for integer. And let's call it x. Make that storage location, give it a name, call it x. And then here you go. That's where we read it in. Now, let's see what happens if we just had one of these in there.
Oh wow.
It's hard to read. But that's what a failure looks like. And that's
All that just for that one missing waka.
yeah. It's actually hard to read the compilation errors from C++. And so main.cpp in function. Now this, it's just a terminal window. I think that means a quote but I'm not sure. So in this function, int main, so there's a problem. Error, and look at this, it gives you the line number 10.
Okay.
And it even gives you a column position 11. So it says, at this point, the compiler said, I determined that there was a syntax error. So that's a good place to start looking. And here it is, error, no match for operator greater than in standard cin, like this. This is, once again, this is a quote. It's just because we're in this terminal window. This should be a quote around here.
Okay.
No match for operator greater than in std : cin. Oh, greater than x, right? So actually it's showing us back our what we wrote. It's showing us it's complicated and hard to read this. But I guess I could actually read through all of this and we can start analyzing it. But we're going to get off on tangents and we'll get in over our heads. Okay, so I'm not going to take that. But let's remember that we've got a line number in here that gives us a hint of where the syntax error is. And the rest of this, let's ignore. So we go to line 10, right? So in VI, I can do it like this. That's line 10. No, and that is in fact where the error is. Let's try 3. Once again, it's a syntax error. It's also in line 10. Expected primary expression before greater than. So it's hard to read. What are they talking about? Primary expression. Well, at this point, let's just say that we won't be able to understand a lot of these error messages from the compiler. But the messages will contain clues that we can use. And the main clue is the location of where the syntax error is occurring. And so once we read in this x, watch this, we can do things. We could say, take the x and say add a 1. And then let's print the x. Because that's a good question. That's a very, very good question. So here, if we did this, we would just print the letter X. We wouldn't print, we want to print the contents of the memory location that's labeled with the name X. So that's, when you use quotes like that, they call that a string literal. And this X is it's referred to as a variable. This is a variable name, or it's an identifier. Now see, it's waiting. So if we type in a 2, it should add 1 to 2 and then print the result. So we should get 3. Okay. There it is. But look at this. It's a little inconvenient. The prompt comes right after the 3. That's because we didn't print a new line. You see how we did the hello, and then we went to the next line, and then bye.
That's with the backslash and the n was for.
Exactly, exactly. So let's put that in here. This is cout. \n. \n is a special character sequence. They call it an escape sequence. And we don't print /n. When the compiler gets to this character here, it says, oh, backslash. Oh, I've got a special operation here. I'm not going to print a backslash. I'm going to read the next value and see what it says. Oh, it's an n. That means I want a new line character. And I can't print a new line character. I mean, a new line character looks like this, right? When you hit the enter key, that's a new. When you hit the enter key in a word processor, you're inserting a new line character. You don't see it. It's called white space or like clear space. You don't see it, but it has an effect on how the text is rendered.
Professor,
Yeah.
can we just put the open quote, the backslash n, and then close quotes? Can we put that after the x?
Yeah, we can. We can, but we have to do it like we can't do it like this.
Okay.
Because this, this here is a string literal,
Right.
and we can't merge that with the variable reference. So the way to do that in one line is like this. And you may see this in the book.
Oh, okay.
Just tell you to do 2 out commands on 1 line.
Yeah. But I want to tell you, and this is very important, how to read this line. There's 2 operations. All the other lines have a single operation. Well, there's no real operation here. It's a declaration. This is an operation. Oh, these are 2 operations. Oh, here's an example of a statement that has 2 operations: addition and assignment. We use the equal sign to represent the operation of assignment. Assignment means take what's on the right and store it into the variable that's on the left. That's what assignment is.
Does that only work with numbers?
No, it works with strings, and it works with pointers, all kinds of things. Now this is also a statement with 2 operations, this one and this one. So when you look at these, you have, just like in math, you have to ask yourself the question, which operation is done first? Well, when you have the same operator, then it's no question. It's the one on the left. So it's a left to right evaluation. Not always, but most of the time. For the output operator, it's always, of course. There are some operators you want to do right to left evaluation, but it's uncommon. And so that means that this part of the statement, and this is a sub-statement. This is cout output operator X. That's a sub-statement. It's like, if you have a sentence in English, and you have, what do they call it? Predicate, and I'm just going back to grade school here. What's the opposite of the predicate? Huh? The subject? Predicate is the verb, right?
I don't know.
You guys don't know? They don't teach that anymore, right? Yeah. I'm from the days where they whack your hand, I was like, what? Anyway, but when you have a sentence in English, you've got these sub-pieces, you've got, clauses in there, prepositional phrases, and, you break it down and understand the components, and then you put it all together to understand the meaning of the whole sentence. It's the same thing with reading computer code. Now, this is a subclause inside the larger statement, and this is this piece of the statement runs first. So what we do is we take the contents of X, not X itself. We don't print X here. We take what X represents, which is a number, whatever that value is, and that depends on what the user types in, by the way. So in the source code, we don't know what it's going to print because we don't know what the user is going to type. So take the value represented by X, send it to the console window, and then when you're done that, let the expression itself be replaced by, and I'm going to say this in a kind of a loose way here, let this expression itself be replaced by Cout itself. So it's called you're evaluating a sub-expression. So what happens is that this, in the next step, this Cout, let me do it like this. This Cout output operator X is replaced by Cout. So so when we do Cout output operator X, it has some effect. It prints X, but then the whole sub-expression also evaluates to Cout. It's replaced by Cout. So that means the second operator then operates on the return value there, the resultant value, which is Cout. This is a little hard to understand, right?
No, it's not, because so you could potentially get an error if you wanted the second command to do something other than Cout.
Exactly right. Right. That's right. That's right. So that's right. So you would get an error. This wouldn't work. That wouldn't work, because that's the same thing as saying, you know, this. So that operation is not defined. The plus operation is not defined for the arguments Cout and a string literal. It's defined for other things. You know, if I did this, it'll be okay, because the plus operator is defined for two strings. That's okay.
Is the out operator, that's only for that command Cout, right? Like you don't use those.
Well, you could use, I mean, it's for streams. So you could use it for other kinds of streams. And actually, the output operator, you can define it. It's flexible. You can define it for different types of arguments. Let me think. I think in this class we're going to use it only for Cout. But there are other places where it could come up. All right.
So you were going to change the plus sign back to the
Oh, yeah.
out operator and then run it.
Yeah, let's do that. It's waiting for a number. I'll put in a 3. Oh, now we get the behavior we want. Good. Adds the 1, gives us a new line. And you may see in the book, the following almost equivalent expression. End line. And there is a subtle difference between the two. You know, when you write things to the output stream, it goes into a buffer. It actually doesn't go all the way to the output stream right away. It goes into the buffer, and then and it may write immediately, or it may write later on. It may leave the buffer immediately, or may leave later on. If you use endline here, you're guaranteed to flush the buffer immediately. But if you use this, if you just output a string, the string may be sitting in the output buffer, not yet made it to its destination yet. There's a kind of a subtle difference there, right? In our class, though, we're not going to deal with this, but I thought I'd mention it. There's a lot of subtle gotchas in programming, and We're going to try to stick to simple, easy concepts. But you can't get away from all of the subtle gotchas all the time. And so, we'll learn to work around them. All right. What do we do next? Now, I wanted to talk about subversion, but maybe it's a little too early. I mean, I like what we're doing here, which is talking about basic syntax and basic concepts. Let's go back. Let's. Huh? Generate a random number?
Yeah. How do you generate a random number?
Okay, let me show you that. That's important in this class. We're going to be generating random numbers. We're going to use random numbers. And there's a function called rand, and that returns an integer.
Oh, so you can put, instead of int, you can put like any type of number you want, right? Like if you want it to be a decimal number, or
Yeah, you could use float.
okay.
So that's called data types.
Yeah, that's what I meant.
So here's a there's a float, and this is coming up. This is something you have to read about. I think it's in chapter 2, right?
Okay.
And these are the different data types. These are similar. It's more common to see a double than a float. And a float is a floating point number. As you can see, I have a decimal in here. And I'm not sure the compiler takes this, actually. I think the compiler does not accept that. And let's test that. I'm going to comment this out. You see that slash slash? That's a single line comment. I'm going to comment this out. So that's very useful for as you're developing, to be able to comment things out. And also you use comments to insert statements in your source code to describe what's going on in your code. So the compiler accepts that. That's all right. Okay. I think in C# they don't accept that. You have to use this this suffix f to say, yeah, it's a float. But so it's language. Different languages have different rules, right?
So if we wanted to generate a random float number,
Yeah.
we just put float x equals and then random in the 2 parentheses? Or does it have to be an integer?
This is an integer. Let's suppose you want a random
Like what if we want
random float. You want a random float, right?
Yeah.
You know what? Let me make sure that rand returns an integer. Actually, it does. I'm sure it returns a. Let's just test this first, and then we're going to find out how do we generate a random
Okay.
decimal number. Okay, let's do the random integer first. So here we're declaring x, and we're calling the rand function. Here we're using a function called rand function. See the open and closing parentheses there? So when you invoke a function like this, you have the function name, and then followed by an argument list, and the argument list has got inside of these opening and closing parentheses. In other words, rand takes no arguments. Well, still need the parentheses.
Right.
Well, see, main is a function that takes 2 arguments, and the arguments in a function are separated by this comma. The first argument in main is an integer called argc. The second argument in main is a pointer to a char, and it's called, oh, I'm sorry, it's more complicated than that. It's an array of char pointer called args. But we're not going to worry about that now, okay? You don't have to worry about that one. And so we're invoking the function rand. Let's run this and see if we get a random number. Oh. rand is not defined in this scope. I should show that to you clearly here. Okay. So when you see these error messages, I recommend you start from the top and read down. And if you have multiple errors, then fix the first one first. So in function int main, all right, so we know that. That's just kind of tells us the name of the function where the syntax error is occurring. It's giving us a line number 7 here. Error. Rand was not declared in this scope. So the compiler is saying that rand is not known. It doesn't know what rand is. So we have to tell it, we have to give it some more information so that it knows where to find this rand. And I got to remember this now. It's a header file. See this include here?
Okay, yeah.
This is called a header file. It's a file that contains declarations of things. Cout is defined in this IOStream header file. So if we needed to include this statement here.
So it knows what cout means.
Exactly. So now we need the equivalent for rand.
Okay.
Who knows what it is? I can guess. Let me see. It's like something like that. C standard lib? No, that's not right. What is the name of the header file? Is it C standard lib? I don't think that's it either. That's it. I guessed it. You wouldn't be able to do that, right? So you'd have to use Google or something like that, or your textbook. Actually, the textbook has that. There's the random number. Yeah.
Those various header files already exist on the machine, correct?
That's right. They exist on the machine. It comes with the compiler. Yeah. Now, I want to show you about this random number generator here. Let's run the program again. It's the same random number.
Yeah, why is that?
What kind of a random number is that? It's because it's actually called a pseudo random number generator. It's not a real random number. This, you wouldn't, data encryption, like when you're on the internet and you're making a credit card transaction and you see HTTPS in your URL, all of that deep down inside depends on the ability to generate true random numbers. So you would never want to use RAND as a part of the process of encrypting a data stream. So it's just a side point there. So now what we need to do here, what we have with the pseudo random number generator, it will generate the same sequence of random numbers over and over again. Let's keep calling it. Let's call it a bunch of times. There's the 4 numbers. Call it again. It's the same 4 numbers. It's the same sequence of pseudo random numbers. Now what we need to do to get a different sequence is we have to seed the random number generator. So it uses an algorithm to compute the next number. And the algorithm depends on a number called the seed. And if you change the number, you'll get a different sequence of pseudo-random numbers. Okay. How do you seed? You seed it like this. Pass in a number. Let's pass in 2. So srand, seed the random number generator. you see we get a different sequence of random numbers, right? The first one here starts with 1, 8. Now our first one starts with 1, 5. We get a different, we've seeded the random number generator. Actually, we've changed its seed. It had a seed to begin with. It was probably 0. But the problem now is we're not changing the seed. So what we do in this class is we're going to use time. We're going to call time with 0 in it and seed the random number generator based on, I think it's the number of milliseconds since 1970, or maybe it's a number of seconds. I don't remember. Anyway, it's fine. It's a number that changes frequently, at least every second, if not every millisecond. I'm not sure.
But it's predictable.
It's predictable, yeah. And you wouldn't want to use it for security, but you could use it for a video game. Yeah. Not that the players are going to be able to predict anything, but they won't be able. That's an acceptable usage. All right. So let's see if we get different sequence of random numbers after running this twice. Well, first of all, we need to build it. Let's run it once, and let's run it twice and see if we get a different sequence. We do. All right, that's it. So we're inserting a seed based on the current time.
So C++ doesn't have the ability to generate pure random numbers?
Yeah, I mean, there's a way to do it. Like you could, say, measure the time between keystrokes that the user has, down to the millisecond, which isn't going to. Well, there's ways of getting randomness, and I'm not an expert in that area, but I know that there are ways. And some languages, like Java, they have something called a secure random number generator, and it's a function that you can call to get a random number that's good enough for encryption purposes. It's still a pseudo-random number, but it still has some flaws in it. But it's good enough. The flaws are not bad. Yeah. All right. So that's great. We've covered a lot today. It's good.
So are we able to change the data type of the random number?
Oh yeah. Let's generate a decimal value now. And the way to do that is once we have the x. By the way, a double means double precision floating point value. That's different than float, which is single precision floating point value. Single precision means the number is represented using 4 bytes of memory. Double precision means double, 8 bytes of memory. And for doing something like financial calculations, where you're concerned about, I don't want to lose a penny, when I'm doing, you want to use a double. And so usually you want to use a double. For things like video games, you're going to use float a lot, because you might have a million numbers that has to do with positions of points in 3D space. And you don't need a double precision. The float is good enough. So you'll see in video games and things that are graphically intensive, that they want to compress the memory because it's a lot of storage requirements there, and you don't need the precision of a double. So you'll see float used in that context. But in general, if you don't have a lot of data that you're dealing with, then just use a double. That's the rule of thumb. All right. So we take the double. What we need to do is take the x, and we're going to divide by something like rand max, and I can't remember, something like this. It's the maximum integer that rand is going to return. So this gives us a number between 0 and 1.
Does that have to be capitalized?
Huh?
Does that have to be capitalized?
Yeah. And by the way, C++, as well as almost all other languages, are case sensitive. So an uppercase A is different than a lowercase a. That's very important to remember. I don't know if rand max works. I'm just guessing here. It's been some time since I used this, so let me try to build with it. It worked. Okay. I feel great. My memory is still there, you know. So it's starting to slip, but all right. So this y is between 0 and 1. Oh, getting a 0 all the time. What's going on there? Oh, this is an excellent illustration of one of the subtle gotchas that we have to handle in this class. And actually, this is something that happens in many computer languages. Why are we always getting a 0? Now, x is less than rand max, okay? Because rand max is it could be rand max, but it's unlikely. Y is y. When I print y, we get a 0. Because the compiler looks at this expression and says, oh, x is an int and rand max is an int, so you're dividing two ints. I'm going to use integer division, not floating point division. And integer division always returns an int. You drop the fractional component of the number. So 4 divided by 2 is a 2. 5 divided by 2 is a 2. Well, 5 divided by 2 should be 2.5, right? But not in the world of integers. In the world of integers, 2.5 doesn't exist. So 5 divided by 2 would be 2. And the remainder of 1 is tossed away. Okay. So how do we fix that? Well, we just need to tell the compiler to use floating point division instead of integer division. And we can do that. We can cast x to an int or cast rand max to an int. And I think it's safer to cast rand max to an int. So we're telling the compiler, hey, when you see rand max, look at it as, I'm sorry, not int. Sorry, that was a mistake. It's a double. Yeah. When you see rand max, don't look at it as if it were an int. Look at it as if it were a double. And now it's going to say, oh, this is floating point division. There, we got our numbers now. Let's run it a few times to see what kind of numbers we get. Once again, they're good numbers. They're all between 0 and 1. And that's the full procedure right there. You don't need more than that. That's enough for the rest of the class. You're going to get all the random you see how to seed the random number generator with time. You see how to get an integer, a random integer, and you see how to take the random integer and convert it to a floating point number between 0 and 1. And a lot of times what you need to do is get a number not between 0 and 1, but between, say, like 1 and 10 or something like that, yeah, whatever. So then you just have to make your expression. Like say 0, but a number between say 0 and 10, you would just multiply by 10. That gives you a number between 0 and 10. If you want a number between 5 and 10, what do? Yeah, good. But you don't want to multiply 10 here, right? 5 and 10, what do you want to do there? Right, because you're starting at 5 and you want to go at most 5 more. So this number that here is left hand side of the interval, And then you just, the multiplier is the length of the interval. And that gives you a value in an interval. This is between 5 and 10. They're all in there. All right, let's see what else we can cover here. All right, let's do this lab. Lab 021. Let's just quickly do this. So write a console program that prompts the user for their name and then displays the sentence, "Hello, user's name, nice to meet you." The code for this program should be in a file named main.cpp and stored in this folder. So that's the convention we're following in this course. Is each lab, you've got the labs are comprised of exercises. So you have the word lab with the lab number followed by the exercise number. And that will be a folder, and your files are in that folder. And then commit yourself into the repository. And I want to show you that. And we probably don't have enough time to go into that in detail, but I'm just going to give you your first impression of the process that you will use to write into the repository. So here we have a folder already. Let's make another folder, mkdir, lab 021. Let's go into there. I'm using a utility called Screen, by the way. It just makes it faster to hop around. So there we go. And there's nothing nothing in the folder. So we're inside lab 021. That's in CSE201. That's inside my root or my home directory. And let's create main.cpp. And we want a program that that prompts the user for their name and then writes this sentence. Okay. I think I have a hello program. I'm going to go back to lab 1. And I'm going to grab this hello program. And I imagine, and I'm doing this to show you, actually I would do it anyway. So it's good, you know, when you write code, you normally don't start from scratch. You copy from somewhere, right? So we're going to start, this will be our starting point, this hello program. And what I'm going to show you, you know, throughout the quarter is, you know, the technique of incremental development. So just do one little step at a time and verify where you are each time. So rather than solving the problem right in this instant, you know, I've got, you know, I made a copy of this hello program, and I want to just see if it builds and runs, just to make sure. Yep, everything's set up. Okay. Now we want to prompt the user for their name. So that means we want to ask them, you know, what their name is. And when we do that, we want to read in what they type.
Okay, yeah.
We're going to read it into a variable called name.
Yeah, you showed us that.
Is that in lab? He showed this to you?
No, I was
Yeah.
just saying, like, you just showed us that scene earlier, like.
Oh. All right, so let's see. It's going to look. Let me go back to the lab here. Lab 2. Let's get that statement just the way I asked. Hello, user's name, nice to meet you. And there's a period there too. And I'm going to put this new line in there. Now this is not going to compile. Let's try it. You know what? I don't want to. If I just do it, you know, you won't see any mistakes, and you'll say, "Oh, that's so easy." You know, but actually, you're going to get errors, and then you got to read this. You have to know what's wrong. What is wrong?
Does it know a function or something?
Well, look, you know, once again, that first line is the same as what we're always getting. There's an error in main. That's the same first line that we got in all the other error messages. So we can ignore that. It's the second line. And remember that a hat, that's like a quote. So name was not declared in this scope. Name. And what's the line number? The line number is 8. In line number 8, name was not declared in this scope. Let's go to line 8. In VIs are easy. I go there. Oh, no, name is saying I don't know what name is. You know, we have to tell the compiler, hey, name is a string. Maybe it thinks, is it a float? Is it a double? Is it an int? No, we want it to be a string. So we have to tell the compiler to make name a string. So we declare it like this. A name. So the data type comes first, which is string, followed by the variable name here. So name, we're telling the compiler, allocate a variable, allocate the memory and so on to store a string and call it name. Once again, the data type comes first and then the variable name. Just like in the argument list here, the data type is int, the name of the variable comes second. Let's see if that works. What's going on there? That's right. Oh, that ran. That ran. But it's not going to do what we want, right? Let's, what is your name? Dave. Hello, user's name, right? So we gotta get the name in there now. So we got to get the name in there. So once again, we're getting here in an incremental fashion, right? One step at a time. Yeah. We got to break this up. We have to print. Well, we got to do something like this. I'm going to break the string there, and then, you know, then we're going to print the user's name here, you know, which will be Dave. And then we're going to print nice to meet you, like that. That's how we want it to look. Yeah, we got to use a variable, right? Yeah. Yeah, that's right. That's right. So we don't want to use this string here because we'll always print only Dave. We want to print the name. All right, seems to work. So there we have an example of input-output. And you know, this is sometimes a little hard to read. You don't have to make it multi-line like this. You can break it out. I mean, in a single line, you can make it a multi-line like this. This is just a style preference, whichever is easier for you to read. All right, so now that we're done this, well, now that we're done that, what I'm going to do here, I'm going to remove a.out. And also I'm going to, I didn't do this in the sequence I wanted to do. And I'm going to take main out of there to empty out the folder. So now I've got those two folders. Main is temporary outside of it. And I have this, I want to show you how to use the repository. Is it really? It's 1:10, right? We have 5 minutes? I'm going to do this quickly. Okay. So, just so if for those who are at that point, they can get started on this today, that would be great. This is the web address. And I want to show you, you can actually go to it on the web. And I emailed everyone their the repository name. So and they all look like this, something like this, first name, last name, like that. Oops. And it's convenient to save your password here. You got to be cautious about security and all that. If someone has your Subversion password, they can write a malicious executable into your repository. And when you check it out, you will get the malicious executable. If you run that malicious executable, it will do bad things to you. It's very unlikely that this happens. I mean, maybe one of you does it to the other in the class. But, other than that, I don't think that would happen. So, but be cautious. You always think about security all the time, okay? But then there's this convenience issue, right? And typing in your password over and over again is very inconvenient. All right, so here is the root folder. I don't have anything in there. And in the lab, I explain what to do. Create this folder, and then do this. So I'm just going to copy this. I'm going to copy this line. This is a one-time thing. You're not going to do this more than once. In fact, what happened? I'm disconnected. Okay. And what I'm going to do, I'm going to show you the whole process here. All right, I'll do it like this. What's the big deal? There it is. Okay. Now you have to edit this part. Now watch this. Do you want to store the password unencrypted? It's very convenient to store the password. But once again, you're trading off there with security. So I don't have to re-enter my password all the time. All right. I know I don't want to go over, so let's finish this up. So here is the lab. So I'm going to do, if you look at the instructions here, I'm just going to do what it says. SVN add. You know what? I don't have to cover this now. Everything is there on the web. You can just read it and do it if you're at that point. I mean, we're ahead right now in lectures, so you don't actually have to get this far. But if you want to, go ahead and try to get that stuff to work. I'll see everybody next week or this afternoon. Yeah.
repository is how you would be checking our work.
Yeah.
And that's also how we turn in our work.
Yeah.
Okay.